So Unit 26, screw, thread, representation, and thread fasteners. So internal and external threads can be represented on drawings in 3 different ways. They may be shown in detailed, schematic, or simplified representation. Examples of external threads drawn used each method are shown in figure 26.1. So you got pictorial, where it actually shows the thread, schematic, where it shows a simplified thing of the thread, and then simplified, where it has no thread whatsoever, just a dashed line in it. Detailed representation is a pictorial or detailed representation show the thread form very close and how it actually appears. The detailed shape is very pleasing to the eye. However, the task of drawing pictorials is very difficult and time consuming. Therefore, pictorial representations are rarely used on threads of less than 1 inch in diameter. Schematic representation does not show the true shape or form of the thread shape. Visual lines are used to show nominal or major diameter of a thread. Crest and root lines are drawn perpendicular to the axis of the thread. Root lines are normally drawn thicker and darker than crest lines. The spacing of the crest and root lines represent the approximate pitch of the thread. A simplified representation used thread symbols to further reduce the drafting time. A visible line is drawn to show the nominal diameter, and 2 hidden lines drawn parallel to the axis of the thread represent the root or depth of the thread. External threads are an external or profile view of a threaded shaft clearly shows the method of representation used. However, when looking at the end view of the threaded diameter, the thread representation will appear the same regardless of the method selected. The crest diameter of the thread will be shown with a visible line. The root diameter will be shown with a hidden line, and if the end of the thread has been chamfered to the approximate thread depth, however, both crest and root diameters may be shown as a solid line. So internal threads. The examples provided in figure 26.2, A, B, and C show how a threaded hole will appear in a section view. Section views of threaded holes provide much more detail as to the thread representation method used. However, in an external profile view, as shown in figure 26.2D, all 3 representations are the same. 1 pair of hidden lines are drawn parallel to the axis of the hole to represent the crest diameter and another pair of hidden lines represent the root diameter. So detailed, schematic, simplified, external, and front. So a front or end view of a threaded hole will also appear the same regardless of the representation method used. Figure 26.2E, the root diameter of the hole is shown as a visible line and a major or nominal diameter is shown with a hidden line. If a threaded hole is chamfered to thread depth, the crest and root diameters may appear on the drawing as 2 concentric visible lines. A tapped hole is a threaded hole that has been cut using a special tap tool called a tap. Taps are standard cutting tools available in English and metric sizes. Before threads can be cut, a hole must be machined using a tap drill of the appropriate size of the thread. Tapped holes may go all the way through a part or to a specified depth. Threads are to be cut to a specified depth are often referred to as blind holes and may be shown in combination with a tap drill hole. The bottom of the tap drill hole is pointed to represent the drill point. Tapped holes are dimensioned with leader and depth symbol. So, what it's talking about there. Alright, threaded fasteners are used for many assembly, clamping, or adjusting purpose in machine work. Common thread fasteners include a variety of screws, nuts, bolts, or studs. This unit provides an overview of some of the fastener hardware most frequently used in manufacturing and assembly applications. Other than on assembly drawings, threaded fasteners are seldomly shown on engineering drawings. However, they may be specified as notation on the print or an assembly part list. Therefore, it is important to the print reader to have basic knowledge of threaded fasteners. Screws are externally threaded fasteners used in assembly applications. Screws may be inserted through clearance holes in parts to be assembled and held in place by a nut. Or it may be threaded into a threaded hole of a mating part. A variety of screw head and drive geometries are available for selection depending on the fastening application. Machine screws are available in standard thread sizes and length. They are used frequently with small diameter fasteners and are required for general assembly work. Machine screws are much like machine bolts or cap screws in appearance. So you got different kind of heads and stuff. So cap screws are stronger and more precise than machine screws and are used for semi-permanent clamping or fastening. As with machine screws, cap screws are commercially available in many thread diameters, head geometries, and drive heads. So set screws are used to prevent motion or slippage between two parts, such as a pulley or collars on a shaft. Set screws are usually heat treated for added strength to resist wear. They may be either headed or headless and with a variety of point form available. Some basic set screws and point variations are shown. Alright, bolts and nuts. Bolts are externally threaded fasteners that can be used in many clamping, holding, and assembly applications. They are generally larger in size, and machine screws and cap screws are available in different grades of hardness and tensile strength. Markings on the head of the bolt specify the bolt's material and grade specification. Table 26.1 provides information of the bolt hole marking grade and material. So if it's no mark, it's grade 1 or grade 2. If there's 3 marks, it's grade 5, and so forth. So 1, 2, 3, 4, 5 marks, it's grade 7. 1, 2, 3, 4, 5, 6 marks, it's grade 8. So pretty much, if you add 2, and it's going to be that grade. Unless they're in a certain pattern or have numbers on them. Alright, so machine bolts are used to clamp or hold 2 or more parts together. They are not as precise as cap screws and are not available in as large of a variety of head forms. Machine bolts have either square or hex-shaped heads. Nuts. Various types of nuts are commercially available for use on assemblies. The designer must select the proper style best suited for each application. Some typical styles of nuts include square, hex, jam, castle, and flange. Studs or stud bolts are headless bolts with threads at each end. One end can be threaded in a mating part and held in place with a nut or a combination of nut and washer. In some applications, a nut and washer may be fastened on the opposite ends of the stud. Studs are frequently used in clamping applications such as securing a part to the machine table. They are commonly used to secure equipment to a floor or base. Washers are often used in combination with screws, nuts, bolts, or studs. Washers help to distribute clamping pressure over a wider area. They also prevent surface marring that may result from a contact with the head of the bolt or screw. Common washers. The most common types of machine washers are in plain flat washer or spring lock washer. Flat washers provide larger load-bearing surface of the head of the bolt. Spring lock washers prevent backing off or loosening of thread fasteners assemblies. Appendix X provides information of the flat washers and spring lock washers. Threaded fastener assemblies. Figure 26.1 or 10 and illustrates several typical threaded fastener assembly applications using screws, bolts, nuts, and washers. In many applications, the screw heads are recessed into assembly by countersinking or counterboring. In typical fastener assemblies. Threaded fastener size. The size of a thread fastener, such as a screw, bolt, or stud, is determined by a nominal thread diameter. The body is used to designate the dimension of the length. However, the thread length may vary with the diameter or style of the fastener. And here would be your assignment.